Good afternoon, dear students. Today we will be going to solve a problem which is based on dot product or dot product, which is also called as a scalar product. Now, you must be knowing the term scalar. Okay? Scalar is what? The quantity, the physical quantity which has only magnitude. It does not have direction. Now suppose here these are the three mutually perpendicular axes in 3D, x, y and z. So x, y and z, these are defined, these are directed along different directions. So here I, j and k are the unit vectors which will give the direction along the three mutually perpendicular axes. Here x, y, z are mutually perpendicular axes. That means angle between the any two axes you consider. The angle between the two axes is equal to 90 degree. Now, here you must know the properties of dot product. So suppose there are two vectors. How you will identify vectors? There will be a bar over them. Bar denotes the direction. Bar denotes the direction. So here there are two vector quantities A and B. Now, if I want to find out the dot product or scalar product, that means what I want only magnitude. I want only magnitude. So here basic formula for this dot product of two vectors is nothing but magnitude of A, magnitude of B and cos theta. So theta is what? A and B, already I told you that these are the two different vectors. Theta is what? Theta is the angle between the two vectors. Now suppose this A is a vector. Vector means it is having magnitude as well as direction. And theta is the angle between these two vectors. Now here unit vectors I, j and k are the unit vectors. So magnitude of unit vector is always equal to 1. Magnitude of I, magnitude of j and magnitude of k will be always equal to 1. Clear? Now when you take dot product, suppose this I and I, these are the two unit vectors. Both are unit vectors but same unit vectors. Here I and j, both are unit vectors but different unit vectors. That means here one unit vector is along x axis, one unit vector is along y axis. Here one unit vector is along x axis, another unit vector is also along x axis. Now by definition of dot product of two vectors is what? Magnitude of first one, magnitude of second one and the angle between the two vectors. So here magnitude of I and since both are coincident vectors, that means same vectors, so naturally the angle between them will be 0. So what will be the result for this? Magnitude of I will be 1, magnitude of I will be 1, cos of 0 will be 1, so output will be 1. Whereas when we take two perpendicular unit vectors, that means one along I is along x axis, j is the unit vector along y axis, that means both are perpendicular unit vectors, so dot product will be equal to 0. How? Magnitude of first one will be equal to 1, magnitude of second one will be also equal to 1, but the angle between the two perpendicular vectors is equal to 0. Sorry, 90 degree. So cos of 90 will be equal to what? 0. So output will be 0 for two perpendicular vectors. So from this I can write down this I dot I, j dot j, k dot k is equal to 1. Similarly, from here dot product of two different vectors I dot j, j dot k, k dot I is equal to 0, but they must be perpendicular. Whenever the dot product is 0, what is our conclusion? That the two vectors are mutually perpendicular to each other. Now consider a problem. Here first vector is given as A, which is nothing but 6i plus 3j minus 2k. Second vector is B, which is denoted as 2i minus 2j plus 3k. Now You want to check whether A is perpendicular to B. So you can solve it easily. When the first vector is perpendicular to second vector, the angle between them will be equal to 0. And when the angle between them will be equal to 0, that means two vectors are perpendicular. So their dot product will be equal to 0. So here A dot B has to be 0 for satisfying the condition of perpendicularity. Now when I take A dot B, first vector I have written this, second vector I have taken this. Now here I will take the product of this. Here I is there, here I is there. So I will take the product of coefficient of I and I only. J and J only. K and K only. Because you see here 6 I dot I is 1, I dot j is 0, I dot k is 0. So I dot I is 1, I dot j is 0, I dot k is 0. So I will take only two same unit vectors while taking the product. So 6 into 2, 12, I dot I will be 1. So I will take this, but I will not take I dot j. It is wastage of time. Here also 3 will be multiplied with minus 2 and j dot product will be taken with j only. And here minus 2 will be multiplied by 3 and k dot product has to be taken with k only. So here I dot I1, j dot j1, k dot k1, but 6 multiplied by 2, 12. 3 product with minus 2, minus 6, and minus 2 multiplied by 3, minus 6. So 12 minus 6, 6, 6 minus 6, 0. So here the product of these two vectors is equal to 0. That means A is perpendicular to B and the condition of perpendicularity is satisfied. Clear? So I hope it is clear to you. If there is any doubt, you can comment and I will try to solve your problem. Okay, thank you.